This is the bonus project for week 2. So before we get started, it's worth noting that this data set is actually super imbalanced. Basically, all of them, exactly all of them, are of category not credit card fraud. So SMOTE would come in very in handy here. But first of all, let's start from the beginning. This data set actually has many entries as of 1 million. So because of that, I decided only to use the fraud train data set and limit it to about 100,000 so that, yeah, so that, we don't have any memory issues. Another thing that I did here, some basic reprocessing, got rid of a lot of the columns. And it's worth noting what I did right here, which is where I casted these features as categories. The reason I did so was because, for example, the jobs, there's so many different types of jobs that if I used one hot encoding for jobs, I was going to have over 2,000 columns and I was going to have massive memory issues. My Google Colab was constantly crashing. And I wanted to have jobs actually be part of the data set and not drop it. So I casted it as a category and got the code. So as you can see here, we have the jobs, but as a number, right? So that's what this did right here. Um, some other things, I changed the DOB because I felt like that's not entirely useful. I actually got the age by using datetime, getting the current year, and we're splitting that by age group as well. And then the one hot encoding that I did it for these categories. As we can see, we only have about 72 columns. So if I did one hot encoding for jobs, for example, then I was gonna have over 2,000 columns. So that's what I did that instead. Um, so this right here is right after I did some smoke. As you can see, it's balanced. It's worth noting that I balanced it for the training, also for the testing, because if the testing is, 100% in balance, where all of them are not credit card fraud, we're not going to get good results. The precision and recall were very bad. So I made sure to also use smoke on the training samples. And for some reason, the support vector machine, it just didn't work. It just kept loading for basically forever. So all the models worked, and the results are here. So random forest did very well. So the decision tree and XGB classifier. So those did pretty well in terms of accuracy, but also precision and recall. So over here, voting, it got even better. I would say voting is probably the best one so far. We have about 96% accuracy, and precision recall on the 90s. Stacking also did pretty well, but I would say it was probably voting classifier with XGB boost and random forest. Those are probably the best results that I've gotten. And yeah.